So, so today, if we are getting into any sort of what you call doubts or anything, do ask. So work, I'll be going a little bit fast. Work is said to be done when the point of application of force moves along the direction of force. So I would have a body out here, and this body will be acted upon by a force. Force is a vector quantity, and this body, this is the point of application. You can take the center also as the point of application, and this body will get displaced. So in grade 9, they show the displacement always along the direction in a linear manner. So I would take the distance between the two bodies, or straight line distance, which is the displacement. Displacement is also a vector. So work is said to be done when the point of application of force moves along the direction of force. That along the direction is very important. And going by a little bit senior approach, work is said to be the dot product of two vectors, that is force into displacement, and this is a dot product. A vector's dot product will always give a scalar, and a vector's cross product will always give a vector. So since I am doing a dot product, this child who is born out of this dot product has to be a scalar quantity. Now you cannot ask, sir, what is the direction of work? Because work is a scalar quantity. Work is not a vector quantity. Though the parents who gave birth to work are vectors, but they were multiplied in a dot product. This product is known as dot product. Dot product, or we also call it as, very good, scalar product. Scalar product. So somebody will now ask, sir, this is a vector multiplication. Can you simplify it for us? So whenever you do a dot product of two vectors, then the actual product is the modulus. This is called modulus, or it is also stands for absolute value. Means in the question, if force was written as 5 Newton east or plus 5 Newton, we'll just take plus 5, just without the action, just the magnitude. So they're always positive quantities into the magnitude of displacement multiplied by cosine of the angle between the two. Multiplied by cosine of the angle between the two. So work is said to be Fs cos theta. This is the actual definition of work, right? It will be written Fs in your textbook, don't worry, because in your textbook they are assuming that the force and displacement are in the same direction. So based on this, let us see some criterias. Criteria number 1, I am giving a force on this in this direction. The displacement is also in this direction. Can you actually give an example? Hitting a snooker ball. The way you hit the snooker ball also goes in the same direction. So now the angle between these two will be how much? 0. So in this case, the angle between the two is 0. So my work will be given as Fs cos 0, and cos 0 is 1. So it is equal to Fs. This is how your book will show. But how the Fs came, this is the mother formula, biggest formula. And put theta equal to 0, cos 0 is equal to 1. Okay? Next scenario. Suppose the force is acting in this direction and the displacement is happening in this direction. The force is in this direction. As I told you, porter carrying weight in a railway platform. You are carrying weight on your head. So the weight is acting vertically down and you are going perpendicularly straight, right? So in this also we will use our same formula. Work is equal to Fs cos 90 degree, because here the angle made will be 90 degree and cos 90 is 0. So W becomes equals to 0. Not bad. गड़बड़ तो नहीं लिख रहा हूँ ना, ठीक ठाक ही लिख रहा हूँ ना, हाँ दिखता है इसका मतलब. Okay, the next one. Suppose a ball is rolling on the ground. A ball is rolling on the ground and the ball's displacement is in this direction. It is rolling and it is displacing on this, but there is a friction between the ball and the ground. So the frictional force will always be acting opposite to the direction of motion. Now in this case, if you see the angle between F and S, it is 180 degree. So here we say work done will be equal to Fs cos 180, and cos 180 is minus 1. So W equal to negative Fs. This in your book in grade 9, they will say if force and displacement are in same direction, work is Fs. If force and displacement are in opposite direction, then work is negative. And if force and displacement are separated by 90 degree, then work is 0. But you know it very nicely. that I need not remember these formulas separately. I'll remember the master formula that work is always Fs cos theta, and this depends upon the value of theta. This now brings us that can you then define, so what about the unit of work? The unit, this is Newton, this is meter, but it is not Newton meter. Newton meter comes when you do a cross product. Since this is a scalar quantity, the unit is joule and denoted by J. So the question may be define 1 joule. This you should write, define 1 joule. So how will you define? 1 joule of work is said to be done when a force of 1 Newton displaces a body by 1 meter along the direction of the force. 1 joule of work is said to be done when a force of 1 Newton displaces a body by displaces a body by a displacement of 1 meter along the direction of the force. ये along कभी नहीं भूलना है, otherwise works computation में always. मैंने फिर देखने की क्या जरूरत है? English लिखो. You might be a little bit different. Write your English. 1 joule of work. Okay, I'll change it now deliberately. 1 joule of work is defined as the amount of work which takes place when a body is displaced by a force of 1 Newton by a displacement of 1 meter in the direction of the force. हमें 3 चीज बात करना है. We will talk about 3 things. 1 जूल, 1 न्यूटन का धक्का, और बॉडी कितना डिस्प्लेस होगा? 1 मीटर. किस दिशा में? फोर्स की दिशा में. अब उसको इंग्लिश में लिखो. 1 joule of work is said to be done when a force of 1 Newton displaces, along the direction of force. Admit, how is the YouTube viewing going on? Very nice. Something. You did some Control C, some paste, then you entered into a new screen. Are I'm without specs, to kya hua yaar? I have not sat under the sun and made my hair white, Very nicely, The Control V option you did, right? I told you, jhoot hai to I have to apply some new technique. You just did some tab with your left hand and then that screen opened and that was the time when you were arrested by me digitally. So you have to move your eyes. है ना? कोई बात नहीं यार. हाँ, वो एक्नॉलेज कर लिया. गुनाह मान लो, उसके बाद मैं कुछ नहीं बोलूंगा. डिफेंड मत करो. अब वो देखते ही समझ में आता है कौन. हो गया ये, ठीक है. अब इसके ऊपर थोड़े 1-2 प्रॉब्लम्स करके देखते हैं. आइए, चलो. Let's do some problem. First problem, question. So let's say force is equal to typical CBSE problem 5 Newton, displacement is equal to 2 Newton, 2 meters, 2 meters along F, along the direction of force. Calculate work. हो जाएगा कि नहीं ऋषिका? कितना होगा वर्क? कितना? 10 जूल्स. बढ़िया. ऋषिका ही तो है वो. ऋषिका वो दूसरे क्लास में रितिशा है. सो आई डू अ लॉट ऑफ गड़बड़. आई कॉल दैट गर्ल ऋषिका. 10 जूल्स. समझ में आ गया ये? हैव यू अंडरस्टूड? ओके, नाउ लेट्स टेक next question. Force is equal to 20 Newton, right? Then displacement is equal to 5 meters. Angle, that is theta, is equal to 60 degree. चाहिए cos 60 का वैल्यू हाफ होता है. हाँ चलो, दे दिया तुमको, दे दिया आपको. Cos of 60 is equal to half. Cos 60 is half. So how much it will be? 50 joules. समझ में आ गया? Thank you. इसका कोई नहीं. She's my wife. Yeah. She was out walking. Na? Then I radioed her. Alpha to Delta, come in, sir. You want to meet her? Shall I call her? मैं बुला लूँ क्या? अच्छा ठीक. गई नहीं तो देखता हूँ. Yeah, just open the door and see. Is she gone or it's? Just see. Is she gone? Huh.
I was joking.
This one, they three wanted to meet you. They asked, who is she?
I
Uh, ठीक है, हो गया, कोई बात नहीं. नाउ एटलीस्ट जान आया जैसा लग रहा है. ठीक है, दिस वन इज डन. कौन सा नहीं अंडरस्टैंड किया बेटा? सेकंड वाला आओ देखते हैं. तो इसमें फोर्स कैसा है? फोर्स इज 20 न्यूटन एंड दिस इज हाउ मच? 5 मीटर. एंगल बिटवीन देम इज हाउ मच बेटा? 60 डिग्री. वर्क का डेफिनेशन क्या होता है? Fs cos theta. Always apply. Here also it is Fs cos theta. But theta was 0 in this case. Cos 0 is 1. आप ये कुछ formulas याद रखिए. Cos of 0 is equal to 1. Cos 30 is root 3 by 2. Cos 45 is 1 by root 2. Cos 60 is equal to half. Cos 90 0. Cos 180 negative 1. So here it is how much? 60 degree. 60 means cos of 60 will be how much? Half. So half of this becomes this. ठीक है? Clear? Nothing great? Okay. So some more problems we will do, which becomes interesting after understanding one concept. Though you, because gravitation is not there with you, you need to understand the concept of weight. नहीं तो बहुत सारे problems आप कर नहीं पाएंगे. Weight and mass. You have an idea? Weight of the body. Okay, so 7th grade में हो गया था ना, तो Mishka will explain everyone now. Okay, let's talk about mass versus weight. This is very important. I don't know why CBSE took this chapter away. Our grade 8s now know this. In the new syllabus it is there. Mass versus weight. Mass means the actual content of matter in a body. Content of matter. This pencil, a stylus has got some amount of say plastic in it. How much plastic is present in it? Okay. Mass is a measure of the content of matter. How much plastic is present out here? Understood? So we'll first discuss mass. Mass is universally constant. That means if the mass of if there is 5 gram or 20 gram of say plastic in my stylus, whether you take it to Venus, Earth, Jupiter, Saturn, wherever you want to take it, how much mass is there? 15 or 20 gram only. ऐसे क्यों लिख रही है? आराम से बैठ, नहीं इधर बैठ. Mass is universally constant, okay? And the SI unit of mass is kg, and mass is a scalar. You never say that the mass of this pen is 15 grams east, west, not. Yeah, you don't say that. Is this clear? Weight का concept थोड़ा सा interesting है, okay? Whenever the concept of weight comes up, you have to actually think of a celestial body. And let's first simplify it. We will think about our celestial body, that is Earth. Clear? Weight means you have to always think about a celestial body. So we are considering our celestial body, which is Earth. Now this is Earth. Clear? And let me put that same, say, pen draw karna to mushkil hai. Let's say a small ball whose mass was out there as 15 gram. Now that ball is on the surface of the Earth. Right? First understand. Like you read about Newton's laws, there is Newton's law of gravitation. Newton's law of gravitation says every body in this universe, पूरे ब्रह्मांड की बात हो रही है, not your Earth, attracts every other body. Every body in this universe attracts every other body with a force which is directly proportional to the product of their masses. Means suppose you want a buffalo, the buffalo is attracting you, you are also attracting the buffalo. That's true, and it's correct. Directly proportional to the product of the masses and inversely proportional to the square of the distance between them. The more you are nearer, the more is the attraction force. The more you are far away, the attraction force reduces. Now the question comes, yes, you're trying to see, very good. You're trying to see why is that attractive force not felt? The reason is, this is called the gravitational force. This is a universal concept, understood? Your mass and her mass is very less. But when you actually bring bodies like Sun and the Saturn, Sun and Earth and Moon, then Mr. Rajiv Rastogi, fark to padta hai. The force will be felt in that case. ठीक है? Now, this was earlier there till last year in gravitation. Now, when you come from the universe concept and you come to your own dear planet, then also this is one body and this is one body. Every body should attract every other body. That means the ball is also attracting the earth is also attracting the ball. But whenever the apple falls, we don't see the earth moving to the apple moving to the earth. That's because it's like this, see? In last class you studied force is mass into acceleration. Agreed? So let's say the earth is pulling the apple with a 6 Newton force, and I say where the mass of the earth is 6, then its acceleration will be how much? 1. Earth is also pulling apple is also pulling the earth, but the thing is that apple's mass is 1, so it has to be, its acceleration is 6. So in whom you will see the movement? The movement will be always seen in the lighter body. Did you understand this example? Earth is pulling the apple is also pulling the earth with the same force, but we don't, it's like just you take a piece of a big magnet and you keep one small pin. What do you see? The pin getting attracted. But if instead of that pin you keep a big bolt and you keep your fridge magnet small magnet, then who will get attracted? The magnet gets attracted. जिसका mass कम है वही तो पहले move करेगा ना. And another way, जिसका mass less है उसका inertia less है, he will immediately respond to the change in state, right? So now we are concentrating on something which is called earth and this. So the earth is pulling the apple is also pulling the earth. Let's forget that part. So weight is the force with which earth pulls an object towards its center. Weight is the force with which earth pulls an object towards its center. Yeah, please. Gravitation is two bodies will be always pulled. There will be an attraction. One of the subset of gravitation itself is weight. Gravitation is a universal concept. See, in gravitation we say two bodies in the universe. You and say, are you all not two bodies? You and Nitya are also two bodies in the universe. But when we come to weight, one of the bodies frozen, which has to be the earth. Now it will be earth versus you, earth versus Nitya. The force with which, is Nitya pulling the earth? Yes. Is earth pulling Nitya? Yes. Are the two forces equal? Yes. But if we throw Nitya up, we don't see the earth going up. She will only fall down because her mass is less. Understood? Force with which an object is pulled towards the center of the earth is called weight. And that force always acts at the center of gravity, means right at the center of the body. So weight, first thing is, weight is a force. Pehla baat hai, weight is a force. And force by which a body is pulled by the earth towards its center. Understood? Now, since it is a force, so what is the definition of, what is the equation of force? Force is mass into acceleration. So the mass will be the mass of that particular apple, and here this acceleration is special. This acceleration we call as g, acceleration due to gravity. This is very special, acceleration due to gravity. Its value is 9.8 meter per second square. People take its problem as 10 meters per second square also, unless specified. So mass into acceleration, this is called small g, and this is the value of earth. Moon also has a g. Moon's g is 1/6 of this. Therefore, if I push you up in moon, you will not immediately fall with your head and nose broken. You will slowly float and come. Because not parachute, moon's G is less. So let's just take an example. Suppose something's mass is say 1 kg. 1 kg multiplied by 10. So you're going to come down with 1 Newton, 10 Newtons. But in moon it will be 1 into 1 by this 10 divided by 6. So it will be coming around at 3 Newton के आसपास. धीरे धीरे आओगे. Colliding the centripetal force. If I move you, you'll also have a force outwards. That is the balance. If you actually take out one, now if you take out one planet from there, the entire things will, suppose tomorrow Mars gets disappeared, your entire season and everything will get changed. Just think, keep a magnet here, central magnet, and keep some 1-2 magnets. They will orient themselves into some equilibrium. Bring a third magnet, again some equilibrium will be. You have got 9 magnets in the solar system and 1 in the center. And this is the equilibrium right now. एक को हटा दोगे तो सब rearrange नहीं हो जाएगा. Either we may come near to the sun or we may get far off from the sun. One or the other things will definitely happen. Jupiter gone means huge amount of impact will happen. Jupiter also has 12 moons of its own. Titan being the biggest moon. ठीक है? Now, force by which a body is pulled by the earth towards its center. But by the way, do you know Jupiter's density is very less? Gaseous. Jupiter is a gaseous. If Jupiter could have been brought on Piramcheru Lake, Jupiter would have floated. Jupiter no, less dense. Jupiter's density is less than the density of water. So Jupiter will float. Okay. Force by which a body is pulled. Now, since this is force, so the next point, this is Earth. If you try to measure the weight of this pen in moon, will the weight change? Yes, the weight will change because mass is constant. G varies from place to place. So this varies from place to place. And then the SI unit is Newton. And it will be a vector. One day we should also ask, when you actually go to a hospital or something, they record your weight and the right kg.
Kg.
No. That also we can discuss. Kg. That many people in engineering final year don't know. Let's discuss that. Why this anomaly is happening. So let's go. Okay, now interesting. Let's take Ryan. And let's say last time he went to a hospital or school or sports meet, his health card was made and there was a section written as weight, and say the teacher had reported 41 kg. Physics wise, this is a wrong reporting. Not physics, science, medical, anyway, this is a wrong reporting. It's just like you ate yippee and you're saying Maggie khaya na main. You washed with Ariel, but you say surf se dhoya hai na. I've washed it with surf because detergent means surf. Noodles means Maggie. This itself is wrong, first of all. Okay, because weight's unit is Newton. Kg is Newton. So now question arises. What was measured? Did we measure his weight or his mass? This is reporting. Then how much is his weight? Pandora's box opens up. So ideally, this whole exercise must have been done something like this. He must be made to stand on a weighing scale. Right? And this weighing scale is actually sitting on planet Earth. Yes or no? So his weight was recorded. No doubt about that. Where is the teacher going wrong? How can the weights unit be kg? Here is the problem of unit system. Unit system. See, modern days we follow SI unit. Right? SI mein there is no issue. SI is a very clear cut. Mass and weight. So let's say we have a boy. If the boy's mass is 40 kg, then his weight will be 400 newtons. As simple as that. Because it will be multiplied by approximately 10. Got it, right? Or 9.8, it will be multiplied by 9. And if report cards were actually reported in SI, then instead of this, it will be reported in Newton and his weight is how much? 400 Newton. But why this kg is still remaining? Before SI came up, we used to have the MKS system. And this is the most horrific one. The MKS. Okay, before MKS, Let me go to the FPS system. Foot pound second. This is the British system. All we countries who were once under the colonial British, the FPS system is very much prevalent still today. If you go to a carpenter and it ask him nails, he will say, 2 inch का कीला लेके आइए, 2 inch. Inch is British. 2 inch. Cakes, pound. My birthday, we got a 2-pound cake. Then when you go to inflate your car tire, भैया पीछे ना 36 कर दीजिए. 36 is what? PSI, pound per square inch. That British thing is there in our mind. And even if you go to countries like Hong Kong, there they will be selling you bananas also. The scale is all in pound. LBS it will be written. क्या लिखा रहेगा? LBS. So here the system is very easy. They will be measuring mass in kg and weight in pounds. LBS. The whole problem is here. MKS. MKS says that mass is to be measured in kg. No issues. But MKS does not see the concept of weight universally. Now, can I measure my weight in Jupiter? Yes. I know my mass on Earth. Carry that data, and you need to have the G of Jupiter. Then just multiply with G. MKS says a very simple thing. MKS says that the unit of mass is kg and the unit of weight is kg force. KGF लिखता है. kg force. kg force. This is the unit. kg force. But in coming days, people slowly evaded the word F. If you still go to our basements and see some pressure gauges on the LPG line, pressure. What is pressure? Force per unit area. Right? Ideally, what have you learned in SI? Newton per meter square, which you call as Pascal. Grade 8. If you are going to a fuel station and you are inflating your tire, then you are again that British ka chamcha. So you will be measuring it in pounds per inch square. Area is an inch square. So this is called as PSI, pound per square inch. How do you say your flat? We stay in a 1300 SFT flat, square foot. Foot is British. But if you see the sale deed was made in meter square. But meter square does not get into our head so quickly. If you tell na his house is 1100 SFT, you can make out how big is 1100. Cricket pitch, 22 yards. That's British. Foot, then yard, furlong, these are all British. MKS says, MKS does not see weight beyond the earth. They see the weight only in earth itself. MKS has a very simple funda. If a body weighs 1 kg mass, I'm wrong. If a body has a mass of 1 kg, then its weight is 1 kgf. Simple. So when RAN was reported for 41 kg, ideally the nurse or the doctor should have written this kgf. So if you see these pressure gauges, there are some pressure gauges. Now this pressure gauge is a MKS pressure gauge. So its unit should be force kgf upon area. When we were in engineering, this used to be our major mistake, kgf per cm square, and finally they'll say report the answer in Pascal. So that's why our conversions are very quick and smart. There is still some manufacturers who still sell pressure gauges, and like idiots they will sell it like kg per cm square. If you are a real hardcore engineer, you should not buy it. You buying it means you don't know the concept of unit. Kg cannot be force. Pressure gauge tells me force per unit area. Either this can be in Pascal, very good, it can be in bar, it can be in PSI, but if it is in MKS, it should be F. So when you go to a shop and you say, Bhaiya, 1 kg peda dena, you're buying peras whose mass is 1 kg and the reported weight is 1 kg force. That force F has slowly become silent. Therefore, people have the habit of writing 41 kg forever. 41 kg cannot be your weight. So let's again ask now, what is the weight of Ryan as per SI? The weight of Ryan as per SI is 410 newtons. यहाँ पे कोई concept, no issues. 40 kg, 400 newton. So here, if you are 40 kg, then you are how much? What is your weight? 40 kg force. Simple. And this is what people goof up. And you just ask somebody, what did you buy tomatoes? 1 kg. Mass or weight? No. You bought 1 kg mass of tomatoes, which was weighed on the planet Earth. And since you reported in MKS, so the weight of those tomatoes was 1 kg force. And if you report it as per the lab language, you'll report it in Newton, then it is 10 newtons. Clear ho gaya? Chaliye. So let's now do one more work problem. Okay. So calculate work done. Okay. So let's see this problem. Right. So we have a person who is climbing steps, right? And let's see. Let's say this distance is 25 meters, and the height of each step is say 1 meter. All right. The mass of this person is our fellow Ryan, 40 kg. Calculate the, acha, tell me, will Ryan sweat by climbing the stairs? Yes, he will sweat. It's an effort. That means you're burning energy. That means you're doing some work. How much work Ryan will be doing in climbing these steps and reaching a point B from A? देखते हैं ये problem. I don't want answer. In physics, we should discuss how to approach this problem. पानी पियोगे बेटा? किसी से पानी ले ले. Tap है. It's not chill. Take the central one. You want to use the washroom, you can use. So did you understand the problem? So we have a body whose mass is 40 kg, and this body is climbing steps. Each step is at a height of how much? 1 meter, and the distance from A to B is 25 meters. Calculate the work done by Ran. He has to do some work, na? That's why he will sweat. How to approach this problem? Go by the basics. Don't try to get an answer. Get the basics. What have I asked you to find out? Work done. Yeah. So shall we now write the formula of work? Work should be what? Fs cos theta. When we do Fs cos theta, then remember one thing. The S should always be in the direction of the F. End of the day. Understood? First, identify the S in this problem. What is the S in this problem? What is S stands for? Displacement. Right? Displacement always stands for, what is the definition of displacement? Shortest straight line distance between initial and final points. Right? So what is the shortest straight line distance? ये तो गड़बड़ हो गया ना? 25 नहीं है. Is displacement a vector? How much did the body move? This is the shortest straight line displacement. To confuse you, I gave that 25. And therefore I wrote 1. The displacement has been only 1 meter, 1 meter, 1 meter. This is the initial point and this is the final point. The vector can slide. So how much is this displacement? 3 meters. How much height did the body gain? As simple as that. You went this way or that way, that is different. This is a problem where we confuse children by the inclined plane. Sometimes if you have to take a patient, and you have to go for more height, then what will we do? The patient cannot be pushed in this manner. So we will give 1 round, again 1 more round. Stairs. We will be 2 layers of stairs will be making 1 and then 1 more stair round. So this is not the displacement. The displacement is this. Ultimately, wo kitna utha? S samajh mein aaya? Very good. You have identified S. So the S is 3 meters. Now you have to also find force. How to find force? And remember, this problem was given to you after I explained weight. So now we have to understand force. Think about Ryan. Why is he sweating? Why is he sweating? When do you sweat? When do you sweat? Simple, just think simple. When do you sweat? When you do work in the sense of what?
Movement.
When you are lifting load, as simple as that, then only you will sweat. Na? But what load is he lifting? Himself. He himself is the body. Right? He himself is the body. So what is his weight? His weight is hanging right from the center of his body. His weight is equal to mass into acceleration due to gravity. Roughly around how much? 400 newtons is his weight. Have you understood this? He has to carry 400 newtons up. This is the weight downwards. So he has to exert exactly 400 newtons. He has to push up also. If he's not pushing 400 up, then some portion of his body will come down. Right? So let's see now. Now, have you got the value of F? We have got the value of F. F is equal to how much? 400 newtons. Agreed? Now comes theta. How about here, Garbar? How did you see the displacement?
Oh, 160.
60.
190.
Where is the displacement? How did you, how much, what is the value of displacement? 3. How did you get 3? 3 means moving from where to where? I told you, na, this body will finally move here. So how much is the displacement? 3 meters. Displacement is in this direction. Where is his weight is in this direction? How will he move? He has to pull himself up. He is doing work. So the force is also in this direction. ऐसे होगा तो ऊपर ही नहीं जाएगा ना. 400 Newton. What is the angle between them? 0. So work done becomes how much? Work done becomes mass into gravity into the height through which the body is lifted. And then you'll slowly see that mgh is also the formula for potential energy. यहीं से तो आता है. Now Ryan goes where? Ryan will be right here now at a height. Now we say he has got energy in him. Is it? Yes. वो नीचे यहाँ पे इसको श्रेयांश को सुला दो और उसको ऊपर से फेंक दो. ये स्मैश होगा कि नहीं? हो जाएगा ना. So this body is now energized. You have taken him up. Now he has the ability. Water, if you take up and you open the, that's how water is coming down to you. ये problem समझ में आया? How much of work is done? Work is force into displacement. What is the force? The force with which you are pulling yourself up. What is the work done in pushing a wall? Wall. Zero. But when you push a wall in a gym, then why do they say that you are you're burning calories? But work done is 0. You are not doing any work. Still you are sweating. और push-up मारने से sweat क्यों करते हो? Floor थोड़ी move हो रहा है. You are the body. You are getting lifted by yourself. Got it? So work is being done. Work done on the floor is 0, but work done on yourself, definitely you are doing work. ये clear समझ में आया? Have you understood this problem? So I think you've given some cough to me only now. So all these the type of questions in work we will be getting is very simple. Either you will be applying directly Fs cos theta or you will be applying some 60 degree, 30 degree. Our next concept is to see the relation between energy and work. This is our next topic. How to see the relation between energy and work. In physics, the unit of energy is also joule, and in physics, the unit of work is also joule, which opens up another discussion point. Sir, how come both of them have the same unit? Are they the same quantity? Yes, they are exactly the same quantity. In physics, energy and work are interchangeable item. If you have energy in your body, you will be able to do work. And if I perform work on you, you get energized. As simple as that. Take a bow and pull its string. You have done work. Force into displacement. Is the bow energized now? Yes. Take her cheek nearby and release the rubber band. Patach! It will hit on her face. Work will be done. Agreed or not? Do some hard work and push up water up on a tank. Is the water energized? Yes. Open the tank, the water will just flow down. So work and energy are just interrelated, they are the same thing. If you perform work on a body gains energy, and once a body has energy, that body can perform work on you. Therefore both are will always be denoted by J and J. Now question comes, suppose there is a body, we have a body and it has an energy content E amount of energy is there with it, and you have actually performed W amount of work on this body. What does the conservation of energy say? Energy can neither be created nor be destroyed. Now obviously you have performed W amount of work, means you have burned down energy. बोलते ना calories break down करो. So you have burned down your energy and you have converted into work, and this work is done on this body. So what happens? You lose minus W amount of joules, and this body will gain that plus W. Energy can neither be created nor be destroyed. Have you understood? So let's see one more interesting example. Let's say we have a drill machine. We have a drill machine. So what is a machine? Again, 3 idiot. Machine हर वो चीज जो इंसान के काम को आसान कराए. पेन के निप से लेके पैंट की जिप तक 1 सेकंड में अप 1 सेकंड में डाउन. Simple. दूर अपने दोस्त से बात कीजिए. Phone. Machine. A machine is someone who will be able to take energy and convert it into mechanical work. A drill machine does not have energy. A drill machine will be dependent upon a plug point, right? From that plug point, it is actually eating up what? Electrical energy. And then it will have a drill bit which will be actually rotating. And this is the mechanical work that it is doing. Yes or no? Okay. Now, we will get a drill machine, say, eats 100 joules. It is eaten up. From where? From the electrical source, electrical energy. Question arises, do you get 100 joules of work? What do you think? A drill machine is taking energy. Machine के पास energy नहीं होता है. Machine सिर्फ energy convert करता है. Give me energy, I will convert it into some sort of work. Mixer grinder, it takes energy from the power point, electrical energy, and it converts it into mechanical work. Toaster takes energy in the form of electrical, converts into heat energy, right? So my question is, suppose this fellow took 100 joules of energy from the electrical source. Does it convert 100 joules to 100 joules in mechanical work? Why not? Machine है, machine का तो काम ही वही है ना. Y'all don't think at all in classes of science. सोचते नहीं हो. What happens on a Sunday afternoon if somebody runs the drill machine? What happens to you? Do you get irritated or not? The sound. Is sound a form of energy? Yes. Will the drill machine bit not get heated when it is drilling on the concrete? It will get heated. So is heat a form of energy? Yes. Right? So the drill machine will have some sound energy. It will have some light energy also. Some sparking will also go on. And then there will be a lot of heat energy. All these are bloody losses for you. These are losses. So say suppose 10 joules are gone here. So how much of mechanical work are you getting? 90 joules. So the efficiency of this machine is 90%. Efficiency is energy input divided by energy output into 100%. I feed you 10 rotis, and you output by input. I feed you 10 rotis and you work worth only 8 rotis. So what is your, because you have to run your body also. So what is your efficiency? 80%. So a good machine is one whose efficiency rate is very, very high. So suppose we have got a very old drill machine. Now wear and tear will increase. The efficiency while I purchased was stamped as 90%. But if you feel now, have you brought, do you remember the day when a new mixer grinder was brought in your house? That day the mixer grinder will just will make a sound. And after 3-4 years, lot of chicken, mutton you have eaten and lot of cardamom, cinnamon you have made a paste. Now the mixer grinder will go like that. So what is happening? The machine is losing its efficiency. The more it's happening means you're burning more. Your pocket is getting costed more. जितना आपको mechanical output चाहिए उतना नहीं मिल रहा है. You're not getting that output. Have you understood? So energy and work are just interchangeable items. Doesn't mean that there is energy. Energy can never be lost nor be created. All 100 joules that you ate have to come out in some output. So what is the output? Some in sound, which you wanted your neighbors to get up. Earlier I used to do just like that, doing nothing. Take a piece of plywood, put it on the floor, and right below me there was a person. Every time they used to drill, so I used to just take a piece of plywood every day. Saturday afternoon, I used to take my blank drill machine. Right in the afternoon, I used to do that. Yeah. No, nobody can say anything. I'm drilling in time, shift hours. So have you understood this? Right. So the concept, what we study in this chapter is all about mechanical energy. What is mechanical energy? Energy that you use for doing mechanical work. You know about wind energy, tidal energy, then hydro energy. Hydro energy is energy that you get from falling water. Solar energy is the energy that you get from the sunlight. Chemical energy that you get from chemical reactions. Your battery or your cell utilizes what? Chemical energy is converted to electrical energy. Right? Acha, can you tell me what is happening? This is a cell. Let's see your common senses. Common sense is not common. This is a plus and minus. What do you get out from this cell? Electrical energy. How is the electrical energy? How are you getting the electrical energy? Grade 8. You must have studied dry cells there. Yeah, cell. But energy cannot be created, not be destroyed. There are chemicals inside it, right? So what is the one line diagram? Chemical energy is getting converted to electrical energy. No mechanical. Mechanical means something has to move. As simple as that. Okay, fine. Now your mobile has run down. What do you do with your mobile? Charge up. What is happening now?
Electrical energy.
क्या हो रहा है? When you're charging your cell, what is happening?
Electric energy is being turned into
Electrical is getting converted back to chemical energy. That's why that is rechargeable reactions and reversible reactions are there. That's why that cell is called a rechargeable cell. Not every cell can be recharged. Those are costly cells. That cell has a reversible reaction. If you give my input as chemical energy, I will run down. That cell becomes electrochemical and electrolytic. Electrochemical when it is actually supplying you electricity. Electrolytic, just like what you studied in grade 8, chemical effects of current. You are supplying electricity and creating a chemical reaction. When you charge, then it's an electrolytic cell. When you are deriving electricity out of it, it's an electrochemical cell. Samajh mein aaya? Right. What is happening in a fan? What is happening in a fan? Electrical energy is converted to mechanical. What is happening in a generator?
chemical energy is being turned into electrical.
What is happening in a generator? We call it DG. How many of you know what is the generator? A one-piece item?
No.
Then what is there?
I've never seen
We call it a diesel generator. What is a generator? A generator has got two items. One is called the alternator and one is the engine. This engine is just like a truck engine. This is manufactured by companies like Kirloskar. It's a truck engine, normal truck engine. What do you feed here? Diesel. As soon as you feed diesel, what does it do? The engine starts. What do you get? When an engine starts, what is the output you get in an engine? Mechanical power you will get. You will have a shaft and this shaft will start to rotate. That's the job of a car. The engine shaft has to rotate. In man's discovery of science, you have to rotate something. The day you can rotate something means you have some command. Rotate. Ultimately, the wheels ghumna hai na. So the central shaft, the engine shaft starts rotating. Have you understood? This is an alternator. An alternator, if it is rotated, it produces electricity. So it will be coupled here by a gear system. First, this will start. You'll see that the noise happens. And then this will couple up with this with a gear system. and then it will rotate the alternator. Have you understood? And then the electricity comes out. So let's see the energy. You actually fed what? Diesel. Chemical energy converted to mechanical energy, converted to electrical energy. चमकू हो यार एकदम, कुछ भी नहीं आता. अच्छा चलो, let's see the electric locomotive. This is the electric locomotive. Have you seen? And it has got something out here. What is this called? It's called the pantograph. Pantograph. This is electric locomotive. And have you seen diesel engines also? Yeah, these are the diesel engine locos. Okay, so commonly where there is no electricity, there will be the diesel locos are there. How are they running? The first thing you will say, sir, this one runs on electricity, this one runs on diesel. Wrong. Both are running on electricity. Both run on electricity. Understand science. In your car, petrol or diesel just moves the shafts which are connected to your engines through gear, to your wheels through gear system. Here, electricity is directly driving the alternator. Electricity directly drives this alternator. And on the wheels of a train, motors are fitted. They are not like, these wheels are just like EV vehicles. Motors are fitted, not like our diesel or petrol cars. Now, what about this diesel engine? The diesel engine has got two sections. Whenever you see a diesel engine, the front section, the driver will be here. This section is completely the alternator. And it will have an engine. The engine takes diesel, runs the alternator, and the alternator will produce electricity which will be running these particular wheels. So when a driver actually, when in our petrol cars, when we are increasing speed, we press the accelerator, more fuel consumption happens. Here, if the driver is actually increasing the speed, he is increasing the current. वो इंजन के लिए नहीं, इसमें कोई पिस्टन विस्टन नहीं है गाड़ी की तरह. This is just like a EV, and this is totally EV. Have you understood? Okay, good. So on our next class, our topic in this chapter is mechanical energies are of two forms. I'll just keep it here: potential energy and kinetic energy. We need to study both these forms, derive their expressions, and also see. So today's end of the day, if the energy content of a body has increased, that means work has been done on the body. And if a body loses energy, that means it has performed work, because work and energy are the same things. It's just like gold and cash money. If you sell gold, cash money बढ़ेगा तुम्हारा, and if you buy gold, cash money घटेगा आपका. So if you have more energy, the work content has reduced, and if you have more work, then your energy content must reduce. ठीक है? चलिए.